close your eyes. Take a slow, deep breath. Feel the gentle weight of the air filling your lungs, and then the quiet release as you exhale. With each breath, let the sounds of your world begin to fade. The worries of the day, the lists of tomorrow, let them all recede into a soft, distant hum. Tonight, we are not here. We are travelers. We are voyagers on a sea of stars. Have you ever considered the ground beneath you, the air you breathe, the very light that allows you to see? We assume it all follows a set of unwavering rules, a cosmic constitution written in the language of mathematics. But what if those rules, the very foundation of reality, were not as constant as we believe? What if the universe itself was slowly, silently, changing its own laws? Scientists, looking into the deepest echoes of time, have found hints of this very thing. A change so profound, it shakes the pillars of physics. Tonight, we journey into this beautiful, unsettling mystery. We will not be alarmed. We will simply wonder. Allow my voice to be your guide as we drift into the heart of a cosmos that is more alive, more dynamic, and more mysterious than we ever imagined. Before we begin our journey, let us gently consider what we mean by these cosmic laws. Imagine the universe as an infinitely complex and beautiful piece of music, a symphony playing out over billions of years. The fundamental constants are the very notes of this symphony. They are the specific, unchanging values that define the character of the music. There's the speed of light, a universal speed limit that nothing with mass can ever break. It is the tempo of the cosmos. There's the gravitational constant, the force that pulls stars into galaxies and holds you gently to the earth. It is the rhythm, the deep, resonant bass note that gives structure to everything. And then there are the more subtle notes, like the charge of an electron or the mass of a proton. These are the values that determine how atoms hold together, how stars ignite, how chemistry, and ultimately, how life itself is possible. For over a century, we have believed these constants were just that, constant, fixed, woven into the fabric of space-time from the very first moment of the Big Bang. They were the dependable, unchanging bedrock upon which we built all of our understanding. But our story tonight begins with a whisper of doubt, a question that arose from looking at the light from the most distant objects in the universe, a question that suggests the symphony of our reality might be slowly, imperceptibly changing its key. Our first destination on this quiet journey is a place of profound importance, though it has no physical form. We are traveling to an idea, a number that physicists hold in a special kind of reverence. It is called the fine structure constant, often represented by the Greek letter alpha. You can think of alpha as the universe's master dial, the primary setting that governs how light and matter interact. It is a pure number, approximately 1 divided by 137. It has no units, no dimensions. It is just a raw, fundamental ratio that dictates the strength of the electromagnetic force. This is the force responsible for almost everything you experience. It holds atoms together. It allows chemical reactions to occur. It is the reason you can see, the reason you can touch, the reason you exist in a solid form. If this number, this alpha, were even slightly different, the universe would be an unrecognizable place. A tiny change, just a few percent, would mean stars could not form in the same way. The fusion process that powers our sun would fail. Carbon, the basis of life as we know it, might not be created in stellar furnaces. The very possibility of complex chemistry, of planets, of water, of you, hinges on this exquisitely precise value. For decades, scientists measured alpha here on Earth in countless experiments, and it was always the same. Perfect, unwavering, a true constant. It was a comforting thought, a sign that the universe, for all its chaos, was fundamentally stable and predictable. But true exploration requires looking beyond our home. It requires us to become cosmic archaeologists, digging into the past by looking at light that has traveled for billions of years. And that is where the first unsettling yet wondrous discovery was made. The comfort of an unchanging universe was about to be replaced by a far more profound and mysterious picture. A picture that we are only now beginning to comprehend as we drift deeper and deeper into the quiet expanse of cosmic time. Now let your mind drift outward, far beyond our galaxy, into the deep black velvet of intergalactic space. We are searching for beacons, for ancient lighthouses that shine across unimaginable distances. These are the quasars. The name is short for quasi-stellar radio source, but this clinical term does no justice to their reality. Imagine a galaxy, 1 billion times brighter than our own sun, all of its light pouring out from a region no larger than our solar system. At the heart of a quasar is a supermassive black hole, an engine of incomprehensible power, devouring stars and gas and dust, and in the process, blasting out jets of energy and light that are among the brightest objects in the universe. This light is a time capsule, because the speed of light is finite. When we look at a quasar that is 10 billion light years away, we are not seeing it as it is today. We are seeing it as it was 10 billion years ago, when the universe was young and still forming. The light from these quasars travels across the cosmos, and on its long journey to Earth, it passes through vast, ancient clouds of gas. These clouds act like a cosmic prism or a filter. The atoms within these clouds absorb very specific frequencies of the quasar's light, leaving behind a unique pattern of dark lines in the light's spectrum, like a barcode. This barcode is a fossil, a chemical fingerprint of the universe at that specific point in its history. And here is the crucial, beautiful part. The exact spacing of the lines in this cosmic barcode is determined by the value of the fine structure constant, alpha. At the time and place the light passed through that cloud. By carefully analyzing the light from hundreds of quasars, astronomers can do something that feels like magic. They can measure the value of alpha billions of years ago in a galaxy billions of light years away. It is the ultimate long-distance experiment, and what they found sent a quiet yet powerful shock wave through the world of physics. The barcodes were not quite right. The spacing of the lines was subtly, but consistently, different from what we measure in our labs today. The measurement suggested that 10 billion years ago, alpha, the master dial of the universe, was slightly smaller than it is today. The change was minuscule, a tiny fraction of a percent. but it was there. The constant was not constant. The implications of this discovery are as vast and deep as the space between galaxies. It's as if we were listening to a symphony that we thought had played the same unchanging melody since the dawn of time, only to realize that the pitch has been slowly, almost imperceptibly, rising. The universe is not a recording, it is a live performance. This idea was so revolutionary, so contrary to the foundations of physics, that the scientific community was, quite naturally, deeply skeptical. A claim this extraordinary requires extraordinary evidence. Perhaps there was an error in the incredibly complex measurements. Perhaps the powerful telescopes, like the Keck Observatory in Hawaii or the Very Large Telescope in Chile, had some minute, systematic flaw that was fooling the researchers. For years, different teams of scientists worked to verify or refute the results. They looked at different quasars, used different analysis techniques, and tried to find any possible source of error that could explain away this strange result. But the evidence didn't disappear. In fact, it grew stronger. It began to seem that this was not a mistake. It was a genuine feature of our cosmos. The fine structure constant really does appear to change over cosmic time. But as more data was collected, the story grew even stranger, more complex, and more wonderful. A new analysis, looking at the universe in all directions, revealed something even more mind-boggling. The change in alpha did not seem to be the same everywhere. It appeared that if you looked in one direction in the sky, alpha was smaller in the past. But if you looked in the opposite direction, it was slightly larger. The universe was not just changing, it was changing with a preferred direction. This idea has come to be known as the cosmic dipole. It's as if the universe has a north and a south, not for magnetism or rotation, but for the very laws of physics themselves. This is a profound challenge to one of the most fundamental assumptions in cosmology, the idea that the universe, on a large enough scale, is the same in every direction. The discovery of a directional change in a fundamental constant suggests a hidden structure to our reality, a deep and mysterious asymmetry woven into the fabric of space-time itself. We are no longer just passengers in a changing universe, but in a universe that has a mysterious, underlying grain, a directionality that we are only just beginning to perceive. So, let us now float in this new, strange cosmos, a universe where the fundamental rules are not fixed in stone, but are more like a slowly evolving script. A universe that has a hidden direction, a cosmic grain. The natural question that arises in the quiet of our minds is, why? What could possibly be causing the very laws of nature to shift and vary across space-time? This question pushes us to the very edge of our scientific understanding, into the realm of speculative, yet beautiful, theoretical physics. One of the most compelling, though still unproven ideas comes from string theory. String theory proposes that the fundamental particles we see, electrons, quarks, photons, are not point-like dots. Instead, they are unimaginably tiny, vibrating loops of energy, or strings. The different ways a string can vibrate correspond to the different particles we observe, much like the different vibrations of a guitar string produce different musical notes. In this framework, Our familiar universe of 3 spatial dimensions and 1 time dimension is not the whole story. String theory requires the existence of extra hidden spatial dimensions. These dimensions are not something we can see or interact with directly because they are curled up or compactified on an incredibly small scale. Now imagine that the size or shape of these hidden dimensions could change over time. If they were to slowly expand or contract, even by a microscopic amount, the theory predicts that this would manifest in our dimensions as a change in the values of the fundamental constants. Our constant, alpha, would not be truly fundamental. It would be a projection, a shadow of the geometry of these higher dimensions. In this view, the slow change in alpha that we observe in the light from distant quasars is the echo of a grand, geometric transformation happening in a reality far beyond our senses. The fabric of reality is not just four-dimensional, it is a rich, multi-dimensional tapestry, and we are only seeing a small part of its intricate, evolving pattern. The dipole, the directional change, could be explained if our three-dimensional universe, our brain as it's called, is moving through these higher dimensions, creating a kind of cosmic wind that makes the constants appear different in one direction compared to another. It is a breathtaking idea, suggesting a reality far grander and more complex than we ever knew. Let us explore another possible answer to this profound cosmic riddle. Let us turn our attention to the greatest mystery in modern cosmology: dark energy. For the last few decades, astronomers have known that the expansion of the universe is not slowing down, as one might expect due to gravity. Instead, it is accelerating. The galaxies are flying apart from each other at an ever-increasing rate. To explain this, physicists have proposed the existence of a mysterious, invisible energy that permeates all of space, pushing everything apart. We call it dark energy, not because it is dark in color, but because its nature is a complete mystery. It makes up nearly 70% of the energy density of the universe. Yet we have no idea what it is. It is a kind of anti-gravity, a repulsive force inherent to the vacuum of space itself. Now, what if this dark energy was not just a simple, constant force? Some theories propose that dark energy is a dynamic field, something that can change over time and vary from place to place. This hypothetical field is sometimes called quintessence. If such a field exists, and if it couples or interacts with the electromagnetic field, then it could be the culprit behind the changing fine structure constant. As the universe expands, driven by this quintessence field, the field itself would slowly evolve. This evolution would, in turn, cause the strength of electromagnetism, our constant alpha, to change along with it. The universe's expansion and the laws of physics would be deeply, inextricably linked. The change we see in alpha would be a direct consequence of the cosmic acceleration. It would be a clue, a tantalizing hint that could help us finally understand the nature of dark energy. In this picture, the universe is not just a stage on which things happen. The stage itself is an active participant, its properties shifting and changing as the cosmic story unfolds. The silent, invisible energy that fills the void is not inert. It is actively tuning the dials of reality, slowly altering the fundamental character of the cosmos as it ages and expands into an unknown future. Now let us take a moment to consider the sheer scale of what this means. The idea of changing constants can feel abstract, a distant problem for physicists in labs and observatories. But let's bring it closer. Let's visualize the consequences. Imagine you could travel back in time, billions of years, to one of those ancient gas clouds through which the quasar light is passing. The value of alpha is slightly smaller there. What does this mean for that corner of the cosmos? The electromagnetic force is a little weaker. The bonds that hold electrons to atomic nuclei are a little looser. This has profound implications. The very colors of light that atoms can absorb and emit would be different. A star in that ancient universe would shine with a slightly different spectrum of light. The fusion reactions in its core, which depend on a delicate balance between the electromagnetic force and the strong nuclear force, would proceed at a different rate. Stars might burn hotter or cooler, live longer, or die sooner. The very elements that are forged in those stellar hearts, the carbon, the oxygen, the iron that are essential for planets and for life, might be produced in different abundances. A universe with a different alpha is a universe with different chemistry. It's a universe with different rules for life. This brings us to a deep and fascinating concept known as the finely tuned universe. The idea is that the values of the fundamental constants in our universe seem to be exquisitely balanced to allow for the existence of complexity in life. If you were to change alpha, or the strength of gravity, or the mass of the electron by just a tiny amount, the consequences would be catastrophic. The universe might have been a fleeting soup of particles that never formed atoms, or it might have been filled with nothing but hydrogen, or it might have collapsed back on itself a fraction of a second after the Big Bang. The fact that the constants are changing, even by a tiny amount, opens up a startling possibility. Perhaps the universe is not finely tuned to one single set of values. Perhaps it is in a state of constant, slow self-adjustment. Perhaps the conditions for life were not always present, and perhaps they will not be present forever. We may be living in a habitable epoch, a fortunate cosmic season where the laws of physics are just right for stars, planets, and observers like us to exist. This thought is not meant to be frightening, but humbling. It connects us to the universe in a more intimate way. We are not just living in a static, machine-like cosmos. We are part of a grand, unfolding process, a universe that is still figuring itself out, still evolving its own fundamental nature. Let us now shift our perspective from the vastness of the cosmos to the inner world of the scientist. Picture an astronomer sitting in a control room high on a quiet mountaintop in the dead of night. The air is thin and cold. Above, the sky is a breathtaking canopy of stars, clearer and brighter than you can imagine. Below, the giant, silent dome of a telescope is pointed at a faint smudge of light, a quasar billions of light years away. For hours, for nights, for years, this astronomer and their colleagues collect the faint, ancient photons from this distant beacon. They meticulously process the data, correcting for the Earth's atmosphere, the instrument's quirks, the Doppler shift from the expanding universe. And then, after all that work, they see it. The subtle, persistent shift in the spectral lines, the signature of a changing constant. The prompt says scientists are in shock. But what is the nature of this shock? It is not the shock of fear or panic. It is the shock of awe. It is the profound, humbling, exhilarating feeling of standing at the edge of a vast, unexplored ocean and realizing that the map you have been using is incomplete. It is the realization that nature is infinitely more clever, more subtle, and more mysterious than you had ever imagined. Every great scientific revolution begins with a moment like this, a moment when a trusted assumption, a bedrock belief, is shown to be wrong. Think of Galileo realizing the Earth was not the center of the universe. Think of Einstein realizing that time and space were not absolute. This discovery of changing constants is a tremor of that magnitude. It tells physicists that their beautiful, successful, standard model of particle physics, which assumes all constants are fixed, is not the final story. There is a deeper theory, a more fundamental reality waiting to be discovered. This is the true joy of science. It is not about having all the answers. It is about the thrill of finding a better question. The shock is the jolt of pure discovery, the intellectual vertigo of having the ground shift beneath your feet, only to reveal a new, more wondrous landscape below. It is the quiet, deeply personal moment when a human mind, through reason and observation, touches upon a truth about the universe that no one has ever known before. And in that moment, the universe feels a little less empty, a little more knowable, and infinitely more magnificent. As we continue to float in this sea of cosmic wonder, let us consider the other pillars of reality. We have focused on alpha, the fine structure constant, because it is the one we can measure most precisely over cosmic distances. But what about the others? What about the speed of light? C. What about the gravitational constant, G? Could they be changing too? Measuring a potential change in these constants is much, much harder. The speed of light, for example, is so fundamental to our definitions of time and distance that it's difficult to design an experiment that could detect its variation. It's like trying to measure the length of a ruler using the ruler itself. If the ruler is shrinking, how would you know? However, some theories do predict that the speed of light might not have been constant in the very early universe. Some physicists have proposed that a much faster speed of light in the first moments after the Big Bang could solve some long-standing cosmological puzzles, like why the universe appears so uniform in all directions. These are speculative ideas currently beyond our ability to test directly, but they open the mind to the possibility that even the most famous of all constants might have a hidden history. Then there is gravity. The gravitational constant, G, determines the strength of the gravitational force. It's what holds galaxies together, what dictates the orbits of planets, and what makes apples fall from trees. It is notoriously the most difficult constant to measure with high precision, even in labs on Earth. Trying to measure its change over cosmic time is a monumental challenge. Yet there are some tantalizing, though highly uncertain, hints from observations of supernovae in the cosmic microwave background radiation that suggest G might have been slightly different in the past. If gravity's strength is changing, the implications are staggering. The rate of the universe's expansion would be affected. The way structures like galaxies and galaxy clusters form over billions of years would be different. The life cycle of stars, which is a constant battle between the inward pull of gravity and the outward push of nuclear fusion, would be altered. The entire cosmic history that we have so carefully pieced together would need to be re-examined. The idea that all the fundamental forces of nature, electromagnetism, gravity, the nuclear forces, might evolving together paints a picture of a universe that is truly dynamic, a single interconnected system where nothing is truly static. The very character of reality is not a fixed state, but an ongoing process, a slow cosmic evolution that we are privileged to witness from our small, quiet corner of the cosmos. Let this thought now settle in your mind. Like dust motes in a sunbeam, the laws of nature are not a rigid set of instructions handed down at the beginning of time. They are more like habits that the universe has developed over 13.8 billion years. And like any habit, they can slowly, subtly change. This perspective shifts our relationship with the cosmos. It is no longer a static, predictable machine, like a giant clockwork mechanism. It is something more organic, more alive. It breathes. The slow change in the fine structure constant, a shift of a few parts per million over billions of years, can be thought of as a single, slow breath of the cosmos, an exhalation that has lasted for eons. This does not need to be a source of anxiety. It is instead a source of profound connection. It means that the universe is not a finished product. It is a work in progress. The story of the cosmos is still being written, and we are not just readers. We are living inside the story as it unfolds. The atoms in your body, forged in the hearts of stars long ago, were created under a set of physical laws slightly different from the ones in effect today. You are a child of a younger, different universe. You carry the memory of that ancient cosmos within you. This idea also has philosophical implications that we can ponder as we drift towards sleep. We often seek permanence and stability in our lives, a solid ground on which to stand. Yet, the universe itself is telling us that change is the most fundamental principle of all. Everything flows. The stars, the galaxies, the planets, and even the laws that govern them are all part of a grand cosmic current. There is a deep peace to be found in accepting this. By letting go of our need for absolute certainty, we can open ourselves up to a deeper sense of wonder. We don't have all the answers, and we may never have them. And that is perfectly all right. The universe is not a problem to be solved. It is a mystery to be experienced. And tonight, as you rest, you are part of that experience. You are a momentary, conscious ripple in this ever-changing cosmic ocean. Allow yourself to feel that connection, that sense of belonging to something so vast, so ancient, and so beautifully, wonderfully in flux. Let's return for a moment to the strange and beautiful idea of the cosmic dipole. Remember, this is the observation that the fine structure constant seems to change differently depending on which direction we look in the sky. This challenges our deeply held assumption that the universe is isotropic, meaning it looks the same in all directions on a large scale. This assumption is a cornerstone of the standard cosmological model, so finding evidence against it is a truly revolutionary act. So what could this directional preference mean? One of the most mind-bending possibilities is that it is evidence of other universes. Some theories, like certain versions of string theory, propose the existence of a multiverse, a vast collection of other universes, each potentially with its own different physical laws and constants. These universes are not necessarily far away in space, but exist in other dimensions, parallel to our own. Our universe might be like a single bubble in a vast cosmic foam of other bubble universes. If this is the case, perhaps our bubble universe has, in the distant past, interacted or even collided with another. Such a colossal event would have sent shock waves rippling through the fabric of our space-time, and it could have left a permanent scar, a lasting asymmetry in the physical laws. The cosmic dipole could be the faint, lingering echo of this ancient cosmic encounter. We are seeing a preferred direction in the sky because that is the direction from which the disturbance came. This is, of course, highly speculative. There's no direct proof of the multiverse, but it is a powerful reminder of how a single, careful, astronomical observation can open up portals to ideas that were once the sole domain of science fiction. It transforms the night sky into a potential crime scene where we are the detectives searching for clues of an event of unimaginable scale that happened billions of years ago. It also adds another layer to our place in the cosmos. If we are just one universe among many, then the specific laws and constants we have are not the only ones possible. They are, in a sense, a local bylaw. This makes our existence both more precarious and more precious. We live in a universe with conditions that are just right for us. But this might be a matter of cosmic geography, a fortunate location in the vast landscape of the multiverse. Now, let's explore the future. If the fundamental constants are indeed changing, this process is not something that has stopped. It is ongoing. The change is incredibly slow, far too slow for us to perceive in our daily lives, or even over the entire course of human history. But over cosmic timescales, the consequences could be dramatic. Let's imagine we could travel billions of years into the future. The universe will be a very different place. The relentless expansion, driven by dark energy, will have pushed the galaxy so far apart that the night sky of a future Earth would be almost completely black, with only the stars of our own Milky Way visible. But if alpha continues to change, the universe will be different in a more fundamental way. Let's assume the trend we observe continues, and alpha slowly increases. The electromagnetic force would become stronger. What would this mean? The nuclei of atoms would repel each other more strongly. This would make it harder for the nuclear fusion processes in the cores of stars to occur. The ignition temperature for stars would have to be higher. Smaller stars, like our sun, might not be able to ignite at all in this future cosmos. The very definition of a star might change. The stable range for atomic nuclei could shift, potentially making some elements that are stable today radioactive in the distant future. The universe could, over eons, become a less hospitable place for complexity. The habitable epoch we spoke of earlier would come to an end. This is not a future we will ever see. The timescales are so vast they defy human comprehension. But contemplating it allows us to appreciate the present moment. It allows us to feel a sense of gratitude for the specific cosmic conditions we find ourselves in. The universe, right now, is in a state that is wonderfully conducive to the formation of stars, planets, and life. We are living in the universe's gentle, life-giving spring or summer. We should cherish it. This long, slow evolution of the laws of nature also gives us a new perspective on our own scientific quest. We are trying to discover the ultimate laws of physics, a theory of everything. But what if there is no such thing as a final, eternal theory? What if the laws themselves evolve? Then our task as scientists is not to find a static set of equations, but to understand the principles of the cosmic evolution itself. We are not just mapping a territory. We are trying to understand the geological forces that are constantly reshaping that territory. The quest for knowledge becomes an infinite and infinitely fascinating journey. Let us now address a feeling that might be gently rising in the back of your mind. The idea of a changing reality can be unsettling. Our minds crave stability and predictability. The thought that the very ground rules of existence are in flux can feel like a form of cosmic vertigo. But we can choose to see it differently. We can frame this not as a loss of certainty, but as an invitation to wonder. Imagine you are walking through a forest you have known your whole life. You know every tree, every path. It is familiar and comforting. Then one day, you notice that the trees are slowly, imperceptibly changing their color, not just with the seasons, but in a new and fundamental way. The bark is developing new patterns. The leaves are taking on hues you have never seen before. At first, you might be disoriented, but soon, that feeling would be replaced by a renewed sense of awe and curiosity. You would start to look at the forest with new eyes. Every walk would become an act of discovery. This is what is happening in cosmology. We thought we knew the forest of the cosmos. Now we are realizing it is an enchanted forest, one that is alive and transforming before our very eyes. This invites us to adopt a mindset of humility. For all our powerful telescopes and brilliant theories, we are still just beginners in understanding the universe. We have read only the first page of an infinite book. This is a beautiful thing. It means there are endless wonders yet to be discovered. It ensures that for generations to come, there will be new mysteries to explore, new questions to ask, and new, breathtaking vistas of reality to uncover. So let go of the need for a static, predictable universe. Embrace the cosmos as it is, a dynamic, evolving, and fundamentally mysterious place. Find comfort not in unchanging laws, but in the endless capacity for change and novelty. The universe is not a sterile museum of fixed exhibits. It is a living, breathing work of art, and its masterpiece is the future, which is always and forever unwritten. Allow this sense of peaceful uncertainty to wash over you. There is a deep serenity in accepting that we don't have all the answers. It frees us to simply appreciate the beauty of the questions themselves as we drift deeper into the quiet mystery of the night. Let's turn our gaze inward for a moment. This journey is not just about the cosmos, it's about us. We, as conscious beings, are the universe's way of knowing itself. The starlight that travels for billions of years finds its ultimate meaning when it enters the aperture of a telescope and, finally, the mind of an observer. The subtle shifts in the cosmic barcode are not just data points on a graph. They are whispers from the past, messages from an ancient universe, and we are the ones who are here to listen. This fact imbues our existence with a sense of purpose and significance. In a vast and seemingly indifferent cosmos, we are the instruments of its self-awareness. Our curiosity, our drive to understand, is not just a human trait. It is a cosmic imperative. The universe is filled with information and with stories written in the language of light, gravity, and the quantum world. Our task is to learn how to read those stories. The discovery of changing constants is a new chapter in that cosmic story, and it's a profound one. It tells us that the universe has a history, not just of expanding and cooling, but of fundamentally changing its own character. This connects us to the cosmos on an even deeper level. We are not separate from this process. The very atoms that make up our bodies were forged in a universe with slightly different rules. The evolution of life on Earth has taken place against the backdrop of this slow, cosmic drift. We are, in the most literal sense, expressions of this changing universe. Our own consciousness, with its capacity for change, for learning, for growth, mirrors the dynamic nature of the reality from which we emerged. So as you lie here, feeling the gentle rhythm of your own breath, remember that you are breathing with the cosmos. Your heartbeat is a tiny echo of the great cosmic rhythm. Your thoughts are ripples in the same field of consciousness that is now, through science, beginning to contemplate its own evolving nature. You are not just an observer of this magnificent, changing universe. You are an integral part of it. You are the point where the cosmos becomes aware of its own wonder. And in this moment of quiet contemplation, you are fulfilling that beautiful cosmic purpose. Let us now consider the tools of this grand discovery. We often think of science in terms of abstract theories and equations, but at its heart, it is a deeply human endeavor built on ingenuity and breathtaking technology. Let's travel to the summits of Mauna Kea in Hawaii, or the high Atacama Desert in Chile. Here, above the clouds, far from the light pollution of cities, sit the great cathedrals of modern astronomy, telescopes with mirrors 10 meters across, larger than a living room, polished to a perfection that defies imagination. These are our time machines. The giant mirror of a telescope, like Keck, or the very large telescope, is a light bucket designed to collect the faintest, most ancient photons in the universe. A single photon from a distant quasar, having traveled for 10 billion years, ends its long journey by striking a pixel on a hypersensitive digital detector inside a device called a spectrograph. This device is the key. It takes the faint, collected light and spreads it out into its constituent colors, its rainbow spectrum, with a precision that is almost unbelievable. It is in this spectrum that the cosmic barcode, the pattern of dark absorption lines, is revealed. To measure the tiny shift in these lines caused by a change in alpha requires a level of stability and precision that is staggering. The spectrographs must be kept in vacuum chambers, with their temperature controlled to within 1,000th of a degree. Any tiny change in temperature or pressure would shift the spectrum and create a false signal. The astronomers who designed and built these instruments are the unsung heroes of this story. They are master craftspeople working at the very limits of what is technologically possible. And then there are the new eyes on the sky, like the James Webb Space Telescope, floating silently in the cold darkness of space, 1,000,000 miles from Earth. While its primary mission is different, its incredible stability and sensitivity will allow for new and independent tests of these cosmic variations. It is a testament to our species' relentless curiosity that we build these magnificent machines, these temples to knowledge, all to answer the most fundamental questions we can ask. What is the universe made of? How did it begin? And what are its ultimate laws? The faint light from a distant quasar, captured by a giant mirror and dissected by a precise instrument, is a thread that connects us directly to the deep past and to the very foundations of our reality. Now, let's allow our minds to play with the aesthetic and artistic implications of this discovery. The universe is not just a scientific object, it is a source of profound beauty. The images from the Hubble or Webb telescopes of swirling nebulas and glittering star clusters are our modern-day masterpieces of landscape art. But the idea of changing constants adds a new, invisible layer to this beauty. It suggests that the cosmic canvas itself is changing. The very palette of colors and textures available to the universe is evolving over time. Imagine a painter who, over the course of creating a masterpiece, finds that the properties of their paints are slowly changing. The reds are becoming deeper, the blues more vibrant. This would force the artist to adapt, to create in a new way. The universe is such an artist. The beauty we see in a spiral galaxy today is a product of the laws of physics as they are now. But a galaxy that formed 10 billion years ago under a slightly different value of alpha would have had a subtly different aesthetic. Its stars might have been a different color, its star-forming regions a different shape. The cosmic web, the grand filamentary structure of galaxies, would have woven itself into a slightly different pattern. We are looking at a universe that is not just expanding, but is engaged in a slow, continuous act of self-recreation. This idea can change the way we look at the night sky. When you look up at the stars, you are not just seeing points of light. You are seeing the products of physical laws. But now you know that these laws may not be eternal. You are looking at a momentary expression of the universe's creative potential. The beauty is not just in the final form, but in the process of becoming. It's in the quiet, underlying truth that nothing is fixed, that everything is in a state of gentle, perpetual transformation. This transforms cosmology into a form of art history. We are not just studying the physics of the universe, we are appreciating the different artistic periods it has gone through. And the most exciting part is that we are living in one of those periods right now, and the art is still being made all around us, on a canvas of unimaginable scale. Let's explore a slightly different perspective. Could there be another explanation for these strange observations? Science is a process of questioning and self-correction. Before we fully accept a conclusion as revolutionary as changing constants, we must explore all other possibilities. What if the constants themselves are not changing, but something else is fooling us? One idea is that our understanding of the atoms in those distant gas clouds is incomplete. We create our models of how atoms absorb light based on experiments here on Earth. Perhaps in the extreme conditions of intergalactic space billions of years ago, atoms behave in a slightly different way that we don't yet understand. This is considered unlikely by most physicists, as the laws of quantum mechanics are incredibly well tested. But it is a possibility that must be considered. Another, more subtle idea is that the effect is not real, but is an illusion created by the way we analyze the data. The process of extracting the value of alpha from a quasar spectrum is incredibly complex. Astronomers have to identify the specific chemical elements in the cloud, model their temperature and density, and account for the fact that the light is passing through multiple clouds on its way to us. It is possible that there is a subtle bias in this complex analysis that we have not yet identified. This is why having multiple independent teams of scientists using different telescopes and different methods is so crucial. Each new study helps to rule out these potential sources of error and build confidence in the result. But perhaps the most intriguing alternative idea is that the constants are not changing, but that the charge of the electron, which is a key component of alpha, is being slowly screened by a new, undiscovered field. Imagine a field that permeates the universe, and as the universe expands and cools, this field changes, slightly altering the effective charge of electrons and other particles. In this case, the underlying law would be constant, but its expression in our low energy world would appear to change. This is a subtle distinction, but an important one for theoretical physicists. It could mean that there is new physics, a new particle or field waiting to be discovered. Whatever the final explanation turns out to be, whether it is truly changing constants, higher dimensions, dark energy, or some new field we haven't yet dreamed of, the conclusion is the same. The universe is not what we thought it was. The observations from these distant quasars have opened a door, and on the other side lies a new, richer, and more mysterious physics. The journey of discovery is far from over. It has just entered a new and exciting chapter. Let us take this idea of change and apply it to our own perception of time. We experience time as a linear flow, a river carrying us from the past through the present and into the future. But physics teaches us that time is more complex. Einstein showed us that time is relative, that it can be stretched and compressed by gravity and motion. Now, the idea of changing constants adds another layer of subtlety to our understanding of time. If the fundamental laws that govern processes are changing, does this mean that the very pace of time itself is changing on a cosmic scale? Think about it this way. Our most accurate clocks are atomic clocks. They measure time, by counting the incredibly regular oscillations of electrons inside atoms. But these oscillations, the very ticking of these atomic clocks, are governed by the fine structure constant, alpha. If alpha was different in the past, then the rate at which those ancient atomic clocks ticked would have been different from our clocks today. A second, as defined by an atom 10 billion years ago, might not be the same length as a second today. This means that when we look back into cosmic history, we are not just looking at a universe that was younger and denser, but one that may have been operating on a different temporal rhythm. The great cosmic symphony may not only have been changing its key, but also its tempo. This is a profound and dizzying thought. It challenges our most intuitive sense of what time is. It suggests that time is not a universal, absolute background, but an emergent property of the physical laws of the universe. If the laws evolve, the nature of time itself may evolve with them. This is not something to be anxious about. It is a philosophical meditation. It reminds us that our human experience of time, with its relentless forward motion and its neat division into seconds, minutes, and hours, is just one limited perspective. The universe may experience time in a much grander, more fluid, and more mysterious way. As you lie here on the cusp of sleep, you are also on the cusp of a different kind of time. In dreams, our experience of time becomes fluid and strange. A lifetime can be lived in a moment, and a single second can stretch into an eternity. Perhaps this is our mind's way of tapping into a deeper, more fundamental reality of time, one that is not as rigid or as linear as we perceive in our waking lives. Allow your own sense of time to dissolve. Let go of the past and the future. Just be here, now, floating in this timeless, cosmic moment. Let's revisit the concept of the finely tuned universe from this new perspective. The classic fine-tuning argument points out that if the constants of nature were even slightly different, life as we know it would be impossible. This has led some to suggest that the universe was intentionally designed for us, or that we must live in a multiverse where all possible combinations of constants exist, and we naturally find ourselves in one of the rare, life-friendly ones. But the discovery of changing constants offers a third, fascinating alternative. It suggests a kind of cosmic evolution or self-organization. Perhaps the universe did not start out with the correct, life-giving values. Perhaps the constants have been wandering and evolving over the eons. Some physicists have proposed models where the universe naturally evolves towards states that are more complex and more stable. In this view, the emergence of life is not a lucky accident, but a natural consequence of a universe that is, in a sense, learning and adapting its own laws. It's a form of cosmic natural selection. Universes or regions of the universe with laws that lead to rapid collapse or sterile emptiness are, in a sense, evolutionary dead ends. But regions with laws that allow for the formation of stable structures, like stars and galaxies, and for the emergence of complexity, like life, are the ones that persist and thrive. This paints a picture of a universe that is not just a stage for life, but is an active participant in its own creation story. It is a system that is constantly exploring the space of possibilities, settling into configurations that are more and more interesting. We are not just lucky beneficiaries of a cosmic lottery ticket. We are the products of a 13.8 billion year long process of cosmic self-tuning. This idea is both beautiful and empowering. It removes the need for an external designer and replaces it with the inherent creativity of the cosmos itself. It suggests that the tendency towards complexity and perhaps consciousness is a built-in feature of reality. The universe, in this view, wanted to create stars, galaxies, and us. Not through a conscious plan, but through the natural unfolding of its own evolving, self-organizing principles. Let us consider the human side of this story once more. Science is not just a collection of facts. It is a culture, a community, a way of thinking. And this community is now grappling with a discovery that challenges its very foundations. This process is fascinating to watch. There are the pioneers, the astronomers who first published the controversial data, who have faced years of skepticism and have had to defend their work with rigor and passion. There are the skeptics, the other scientists who rightly demand extraordinary evidence for an extraordinary claim, and whose critical questioning is an essential part of the scientific process. Their role is not to obstruct, but to ensure that the conclusion is robust and that all other possibilities have been exhausted. There are the theorists, the physicists who work with pen and paper or complex computer simulations, trying to build new models of reality that can accommodate these strange new facts. They are the dreamers, the architects of new ideas, proposing everything from hidden dimensions to evolving dark energy. And then there is the broader scientific community, watching and waiting as more data comes in, as the evidence slowly builds, and as a new consensus gradually begins to form. This is how science works at its best. It is not a sudden eureka moment, but a slow, careful, and sometimes contentious conversation. It is a global, multi-generational effort to piece together a puzzle of infinite complexity. There is a deep and quiet beauty in this process. It is a testament to what humanity can achieve when we work together, when we are guided by evidence, logic, and a shared sense of wonder. The discovery of changing constants is a reminder that the scientific journey is never over. There is always a new frontier, always a new mystery just beyond the horizon. And the debate and discussion happening right now in the halls of universities and at scientific conferences around the world is the sound of humanity taking its next collective step into the unknown. It is the sound of our species continuing its ancient quest to understand our place in the cosmos, a quest that is as old as consciousness itself. As we drift closer to the edge of sleep, let us reflect on the very language we use to describe these phenomena. We talk about laws of physics as if they were edicts handed down by a cosmic lawmaker. We talk about constants as if they were designed to be permanent. But perhaps this language, inherited from a different era of thinking, is holding us back. What if we were to think of them not as laws, but as habits of the universe, as we touched on before, or perhaps as patterns of nature? A pattern could be stable for a very long time, but it can also evolve and change. A river carves a pattern in a landscape over eons, But that pattern is not fixed forever. A new flood, a geological upheaval can change its course. The universe might be similar. The patterns of interaction between particles and forces that we observe today are the result of 13.8 billion years of cosmic history. They are stable, but not necessarily eternal. This shift in language from law to pattern or habit can have a subtle but profound effect on our mindset. It makes the universe seem less rigid, less deterministic, and more creative. It also makes our role as scientists seem less like that of a detective uncovering a pre-written code, and more like that of a biologist or an artist studying and appreciating a living, evolving system. Let's try another metaphor. Think of the universe as a piece of software. The standard model of physics is like the current version of the operating system. It works incredibly well, but the discovery of changing constants is like finding a log file that shows that the system has been receiving slow, automatic updates from an unknown source over billions of years. There is a deeper program running in the background, a meta-law that governs how the everyday laws themselves change. The ultimate goal of physics, then, is to understand that deeper program. This is the search for a theory of everything, a theory that would not just describe the patterns we see, but explain why they are what they are and how they evolve. This is the grand challenge for the next generation of physicists, a challenge born from the faint, ancient light of distant quasars. Let us now imagine ourselves as cosmic travelers, but with a new ability. Imagine we could tune the constants of nature ourselves just by turning a dial. What would we see? Let's turn the dial for alpha, the fine structure constant, down, back to what it might have been in the very early universe. The electromagnetic force becomes weaker. Electrons are more loosely bound to atoms. What does this do? Well, atoms themselves become larger. The world would, in a sense, be puffier, less dense. Chemical bonds would be weaker and easier to break. Maybe life in such a universe would be more fragile, more ethereal. Now let's turn the dial the other way, increasing alpha beyond its current value. The electromagnetic force gets stronger. Electrons are gripped tightly by their nuclei. Atoms shrink. Chemical bonds become incredibly strong and rigid. Perhaps the world becomes too stiff for the flexible chemistry that life requires. The very processes of life, which involve the constant making and breaking of chemical bonds, might grind to a halt. Now let's find the dial for gravity, G. Let's turn it down. The universe becomes a place of gentle, slow attraction. Stars might struggle to form, as the gas clouds would not collapse as easily. Planets would need to be much closer to their stars to stay in orbit. The whole cosmic dance would become slower, more lethargic. Now let's turn gravity up. The universe becomes a more violent, dramatic place. Stars form quickly and burn out fast, perhaps too fast for life to evolve on their planets. Black holes would be more common and more powerful. The universe might have collapsed back on itself long ago. This is not just a thought experiment. It is what physicists do with their computer simulations. They create virtual universes and change the settings to see what happens. And what they find is that our universe, with its specific set of values, exists on a knife's edge. It is a delicate balance. The fact that this balance might be slowly shifting over time makes our cosmic moment feel even more precious, more unique. We are living in the sliver of cosmic history, the narrow range of the cosmic dial, where the universe is just right. So, where do we go from here? What is the next step in this epic scientific detective story? The future of this research lies in more data and more precision. Astronomers are designing a new generation of instruments and telescopes specifically to tackle this question. There are plans for even larger optical telescopes on the ground, with mirrors 30 or even 40 meters in diameter. These will be able to collect light from even more distant and fainter quasars, allowing us to probe the universe's history with greater detail and accuracy. There's a new generation of spectrographs being built, using technologies like laser frequency combs to achieve a level of stability and precision that was previously thought impossible. These instruments will be able to make a definitive measurement of the change in alpha and confirm or refute the tantalizing hints of the cosmic dipole. Another exciting frontier is looking for these variations in other ways. One method is to use the cosmic microwave background, radiation, the faint afterglow of the Big Bang. The patterns of hot and cold spots in this ancient light are sensitive to the value of alpha. At the time the radiation was released, about 380,000 years after the Big Bang. By studying these patterns with ever greater precision, with missions like the Simons Observatory, we can get a snapshot of the laws of physics in the universe's infancy. Another method is to look for tiny, yearly variations in the frequencies of atomic clocks here on Earth. Some theories that predict a changing alpha also predict that it should oscillate slightly as the Earth moves through the galaxy's gravitational field. These are incredibly difficult measurements to make, but the technology of atomic clocks is improving at a phenomenal rate. The quest is on. The evidence is mounting, the tools are getting better, and the mystery is deepening. Within your lifetime, we may move from the first tentative hints of a changing reality to a new, accepted picture of our cosmos, a new cosmology, where the evolution of physical laws is a central part of the story. The quiet, patient work of scientists today is laying the foundation for a revolution in our understanding of everything. As our journey nears its end, let's allow all these thoughts to merge and settle. We began with a simple, comforting idea that the universe is governed by eternal, unchanging laws. We have journeyed through space and time, following the faint light of quasars, and have arrived at a new, more complex, and more wondrous understanding. The universe is not static. Its fundamental character is evolving. The strength of the forces that shape reality is in a state of slow, cosmic flux. This might even happen with a preferred direction, a hidden grain in the fabric of space-time. This change could be a sign of hidden dimensions, a whisper from a grander, multidimensional reality. Or it could be the influence of the mysterious, dark energy that is driving the cosmic expansion. Whatever the cause, this discovery reframes our place in the cosmos. We are not living in a finished creation, but in a universe that is still in the process of becoming. We are the products of a long cosmic evolution, a process that has not only shaped stars and galaxies, but the very rules they follow. This knowledge does not diminish the universe, it enhances it. It makes it more mysterious, more organic, and more beautiful. It transforms the cold, empty void of space into a place of active, creative potential. It reminds us that for all we have learned, the age of discovery is not over. In fact, it may have just begun. We live in a privileged time, a moment in human history when we are finally able to ask these profound questions and have a genuine hope of finding the answers. The signals have been traveling for billions of years, waiting for someone to be here to receive them. And we are here, listening, wondering. Let this final thought be your gateway to sleep. The universe is not a silent, empty place. It is a place of deep, slow music. And tonight, you have learned to hear a new note in its ancient, beautiful, and ever-changing symphony. Let us contemplate the very nature of discovery itself. We often imagine scientific breakthroughs as sudden flashes of insight, a single eureka moment. But the story of the changing fine structure constant shows us a different, more realistic picture. This was not a single discovery, but a slow, painstaking process that has unfolded over more than 2 decades. It began with a hint in the data, a small anomaly that most might have dismissed as an error. But a few dedicated researchers pursued it, driven by curiosity and a commitment to meticulous measurement. They faced skepticism from their peers, struggled for funding and telescope time, and worked for years in the quiet obscurity of their labs and offices. The story is one of perseverance, of intellectual courage, and of a deep, unwavering faith in the power of the scientific method to reveal the universe's secrets. No matter how strange they may be, this is a deeply human story. It is about our innate desire to push beyond the boundaries of the known, to explore the darkness with the small candle of our reason. It is a story about collaboration across continents and cultures, as different teams of scientists built upon each other's work, sometimes competing, sometimes cooperating, but always pushing the collective enterprise forward. And it is a story that is still being written. The final chapter has not yet been penned. We are living through the scientific revolution in real time. This adds a special poignancy to our cosmic lecture tonight. We are not just recounting a story from a history book. We are witnessing the very process of history being made. As our species collectively lifts its gaze to the heavens and dares to ask a question that shakes the very foundations of our reality. Are the laws of nature truly constant? The answer, it seems, is a beautiful and resounding no. And in that no, 1,000 new questions, 1,000 new possibilities are born. Let's consider the scale of this change from another angle. The variation in the fine structure constant observed over 10 billion years is just a few parts per million. This is an unimaginably small number. To put it in perspective, imagine a journey from New York to Los Angeles. A change of 1 part per million would be a deviation of just a few feet over that entire distance. So why does such a tiny, tiny change matter so much? It matters because the thing that is changing is supposed to be absolutely perfectly constant. It's like measuring the speed of light every day for a year and finding that on Tuesdays, it's a fraction of a millimeter per second slower. The amount is trivial, but the fact that it changes at all is revolutionary. It breaks the symmetry. It shatters the assumption of perfection. In physics, these tiny deviations from expectation are often the cracks through which the light of a new, deeper theory shines. Einstein's theory of general relativity, for example, was confirmed by measuring a tiny, almost imperceptible wobble in the orbit of the planet Mercury, a deviation that Newton's theory of gravity could not explain. The standard model of particle physics was confirmed by finding new particles in the debris of colossal accelerator collisions. Particles that were predicted by the theory but were incredibly rare and difficult to detect. Science often progresses by measuring things with ever greater precision. It is in the 5th or 6th or 10th decimal place that the secrets of the universe are often hiding. The story of the changing constants is a supreme example of this principle. It is a triumph of precision measurement, a testament to our ability to build instruments that can detect the most subtle of cosmic whispers. It teaches us a valuable lesson. Sometimes the biggest discoveries are found in the smallest of details. The universe speaks to us not only in the grand spectacle of supernovas and colliding galaxies, but also in the quiet, subtle shifts in the ancient light from the edge of time. We just need to learn how to listen with enough care and precision. Now, as we prepare for the final descent into deep, restful sleep, let us allow our minds to become like the universe itself, vast, quiet, and open to possibility. Let's release our grip on our familiar, earth-bound reality and float in this larger context. Think of the planet beneath you, a small, beautiful sphere of rock and water, orbiting a very average star in a quiet corner of a vast spiral galaxy. This galaxy, our Milky Way, contains hundreds of billions of other stars. And beyond our galaxy, there are hundreds of billions of other galaxies, stretching out as far as our telescopes can see. For most of human history, we believed this vast cosmos was a static backdrop, a fixed and eternal stage on which our small human drama played out. But now we know better. The stage itself is part of the play. The scenery is shifting. The rules of the drama are evolving. This is a far more exciting and engaging picture. It means we are part of something that is alive and unfolding. We are not just spectators. We are participants. The atoms in your body have been on an incredible journey, forged in the heart of a dying star billions of years ago. They have drifted through interstellar space, been part of a collapsing nebula, formed a planet, and have now, for a brief and precious moment, assembled themselves into you, a conscious being capable of contemplating this entire magnificent story. And you're doing so at a unique moment in cosmic history. A moment where the physical laws are just right for your existence, and a moment in human history where you are able to learn of their deep, slow, and wondrous evolution. This is a thought of profound peace and connection. It dissolves the boundaries between you and the cosmos. You are not just in the universe. You are the universe, experiencing itself. Let this feeling of cosmic unity be your anchor as you drift off. Let go of your sense of a separate self. Merge with the vast, quiet, and ever-changing whole. You are safe. You are part of everything, and everything is in a state of gentle, perpetual, and beautiful transformation. Let's imagine one final journey. A journey not in space, but in understanding. We've traveled far tonight, from the concept of a constant to the light of distant quasars, to the frontiers of string theory and the multiverse. We've seen how a single, subtle observation can ripple outwards, challenging our most fundamental assumptions about the nature of reality. The shock of the scientists is not one of fear, but of profound, humbling awe. It is the feeling of a cartographer who discovers that the continent they have been mapping is not fixed, but is, in fact, slowly drifting. The map must be redrawn, but the new map will be infinitely more interesting and true. This is the nature of our relationship with the cosmos. It is a perpetual dialogue. We ask questions with our telescopes and experiments, and the universe answers. But its answers are often more subtle and mysterious than we expect. It does not give us simple, final truths. It gives us deeper questions. The discovery of changing constants is one such answer, one such question. It asks us to reconsider what we mean by a law, what we mean by time, what we mean by reality itself. It invites us into a new era of physics, an era that promises to be as revolutionary as the dawn of relativity and quantum mechanics a century ago. We are fortunate to be alive to witness the beginning of this new chapter. As you drift now, let your mind be at peace. You have taken a long and wondrous journey. You have glimpsed the deep, hidden dynamism of the cosmos. You have touched upon one of the greatest mysteries of modern science. And now, it is time to rest. Let the vast, quiet, and slowly changing universe hold you as you sleep. Let the gentle, cosmic symphony, with its shifting notes and evolving melodies, be your lullaby. The mysteries will still be there tomorrow. But for now, there is only peace, only quiet, and the gentle, endless, cosmic drift. Consider the silence of space. We often think of it as an empty, silent void. But we have learned tonight that this silence is full of stories, full of information. The light traveling from a distant quasar is a silent messenger carrying a story that is 10 billion years old. That story is written in a language of photons and spectral lines, a language that we have only recently learned to read. And the story it tells is one of a universe that is more complex and more dynamic than we ever imagined. The silence of space is also the silence of these vast, cosmic processes. The change in the fine structure constant is happening without a sound. The expansion of the universe is a silent explosion happening everywhere at once. The slow dance of galaxies, the birth and death of stars, all of it happens in a profound, deep quiet. This can be a source of immense peace. In our own lives, change is often accompanied by noise, by friction, by struggle. But the universe shows us another way. It shows us that the most profound transformations can happen in a state of deep, majestic silence. As you listen now, not with your ears, but with your mind, try to hear that silence. Try to feel the quiet relentless, and peaceful unfolding of the cosmos. Let that silence enter your room. Let it fill the space around you. Let it quiet the chatter of your own thoughts. There is nothing you need to do. There's nothing you need to solve. You are simply a witness to this silent, cosmic masterpiece. You are a part of this deep, peaceful, and endless quiet. This quiet is the true sound of reality. It is the background hum of existence. And in this quiet, you can find a deep and restorative rest. Allow it to cradle you, to soothe you, and to carry you into a peaceful and dreamless sleep, floating in the silent, ever-changing, and beautiful universe. Let us reflect on the idea of a theory of everything. For decades, this has been the holy grail of theoretical physics. The idea is to find a single, elegant mathematical framework that can unite all the forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, into one coherent whole. Einstein spent the last 30 years of his life searching for such a theory, without success. The discovery of changing constants makes this quest both more difficult and more urgent. It's more difficult because any new theory must not only explain the forces as they are today, but must also explain why and how they change over cosmic time. A theory of everything cannot be static. It must be a dynamic theory, a theory of cosmic evolution. It's more urgent because the fact that the constants are changing is a powerful clue, a message from the universe that is pointing us in the direction of this deeper theory. It is telling us that our current theories, like the Standard Model and general relativity, are incomplete approximations. They are like a map of the coastline that doesn't show the tides. The changing constants are the tide. They reveal the dynamic interplay between the deep ocean of reality and the familiar shore of our observations. Theories like string theory are attempts to map this tide. They are the first speculative sketches of what a dynamic theory of everything might look like. They are not yet complete, and they are not yet tested, but they represent the direction in which physics is now heading. The search for the theory of everything has become the search for the meta-laws that govern the evolution of the laws themselves. It is a quest of breathtaking ambition and profound philosophical depth. And it is a quest that was given a powerful new impetus by the faint, fossilized light of ancient quasars, a light that whispered a secret across billions of years. The universe is not just what it is what it is becoming. Let us end our journey with a final meditative thought. The universe does not need our understanding to be beautiful. It was beautiful for billions of years before any conscious mind existed to perceive it. The swirling gases of the Orion Nebula, the majestic rings of Saturn, the silent dance of colliding galaxies, their beauty is inherent, objective, and independent of any observer. And yet, there is a special kind of beauty, a second layer of wonder that comes into being only when we do observe it, when we do understand it. The knowledge that the light from a galaxy has traveled for 1,000,000 years to reach your eye adds a layer of temporal depth to its visual beauty. The knowledge that the atoms in a star are undergoing nuclear fusion, creating the elements that make life possible, adds a layer of intellectual beauty to its simple, shining light. The discovery of changing constants adds yet another layer of beauty to the cosmos. It is the beauty of impermanence, the beauty of evolution, the beauty of a story that is still unfolding. It transforms the universe from a static object of contemplation into a dynamic, living process that we are a part of. This is perhaps the greatest gift that science gives us. It does not strip the universe of its mystery and beauty. It enhances it. It gives us new eyes with which to see, new ears with which to hear the silent music of the spheres. It allows us to appreciate the cosmos, not just for what it looks like, but for what it is. And what it is, we have learned tonight, is something far stranger, more dynamic, and more wonderful than we ever dared to imagine. Let this feeling of enhanced, deepened wonder be the final thought that carries you into a deep and peaceful sleep. Rest now in the heart of this beautiful, mysterious, and ever-changing universe. So, here we are, at the end of our gentle voyage. We have drifted on the gentle currents of cosmic light, traveling billions of years into the past. We have stood alongside scientists as they felt the profound shock of awe, realizing that the very bedrock of reality is not solid, but fluid. We have learned that the universe is not a static machine, but a living, breathing, evolving entity whose fundamental habits are slowly changing over eons. The symphony of creation is not a finished recording. It is a live performance, and its melody is still being composed. This is not a cause for alarm, but for wonder. It connects us to the cosmos in the most intimate of ways. We are living expressions of this changing universe, temporary and beautiful patterns in an ever-shifting cosmic tapestry. Thank you for joining me on this journey tonight. I hope it has brought you a sense of peace, wonder, and a deep connection to the magnificent mystery of which we are all a part. If you have enjoyed this quiet exploration, please consider subscribing to the channel and liking this video. It helps our small corner of the cosmos reach others who might be seeking a peaceful night's rest. And now, for one final thought to carry you into your dreams, if you could ask the universe one question about its deepest secrets, what would you ask? Share your thoughts in the comments below when you awaken, refreshed, and renewed. But for now, just rest, sleep well, dream of the stars,